Okay, continuing on number 9 from the review packet. So for this one, um, another sequence of rigid motion transformations. What it looks like we're going to need to do is first we check orientation. Okay, for both triangles, if you travel A to B to C, you're heading in a clockwise direction, and for D to E to F, it is in the same direction. So again, orientation's equal, so it's really no need for a line reflection. Okay, so no line reflection needed. So what we will do next is then we'll move to the other two requirements. We'll match one pair of points, and then we'll rotate to finish. So the way to do that is, so our first move is going to be translate, and all you're looking to do is match a pair of corresponding points. So really simple. I like to go one at a time here. Let's try to match A to D. So we're going to translate triangle ABC so that A maps to D. Okay. Now you could quick sketch that. That helps a little bit. Everything's gonna move that way. So it looks like C. Going to try to go in that same direction. C is probably going to be about what, right about there. It's going to be A prime. B prime looks to be right about there, right? So it looks like we're going to have this. Right, that's translating from there to there. Now, the second move is we're going to have to rotate so that B prime maps to E, but we're going to have to center that. So we're going to rotate triangle A prime, B prime, C prime. Now you got to mention the center. So we're going to center it at D by an angle that maps B prime to E. So that's going to put 2 points in orientation matched, and that's all it's going to take. Because the triangles are congruent, everything's going to be fine after that. Okay, so 2 points in orientation, and that's enough. All right, last one is C. So again, we start with the orientation. It's always our first look. That's a clockwise orientation for triangle ABC. For triangle D to E to F, right? What we're doing is we're heading counterclockwise now. Okay, so orientation is not preserved. Orientation is going to be not equal. So we need at least one line reflection. So we're going to just use one. We're going to need a line reflection. Of course, two of them would switch the orientation back to wrong, and then a third one if we needed to, but let's not do that. We're going to just go with one line reflection. And what I like to do is, I think a lot of you would just rather just go over one of the sides. I'm going to go over the perpendicular bisector of A to D. It's a little strange, okay, but what's going to happen with that move, okay, perpendicular bisector, that's not, let's go perpendicular bisector of AD, okay. Now what that's going to do is that's going to map A to D. So first move, we're going to line reflect triangle ABC over the perpendicular bisector of AD. Now that's going to accomplish two goals. It's going to fix orientation and map A to D. Okay, I'll just write that down. You don't have to write this in your explanation, but fixes orientation and maps A to D. Okay, a little tricky on this, of course. They're all going to move. It's going to be tricky here. So they're going to move perpendicular to that line. All the points. Let's try to estimate. Okay, right about there for B prime. And real quick estimation right about there for C prime. All right, so what we're going to have is something that looks a little bit like this. I know that's awful, but you know, I'm freehanding it and just trying to get close. You can sketch it in this because we talked about, you know, what that is. All right, now what we do is, all we're going to do is finish it with a rotation. So we're going to rotate triangle A prime, B prime, C prime, centered at, again, D by an angle that maps, what do we want? Well, we'll just go B prime to E again. And again, that's going to do it for us. That's 2 points and orientation fixed. That's going to be enough. Okay, down to the next one. What we have is I want to prove these triangles congruent. What else do I need to know if I'm going to use side, side, side? Okay, so what we got is 2 pairs of corresponding sides congruent already. And if we're going to use side, 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 we need a third pair. So I'm going to need BC to be congruent to KL. That's going to give me my third pair of sides. So this is a pretty neat problem. Complete what is missing, right? Side angle side. So the angle is going to have to be located between the pair of sides. We're going to need angle A congruent to angle J for that, right? We're going to need these two angles congruent. And if we want hypotenuse leg, we really can't use a congruence. We've already got hypotenuse and leg. Let's scratch this. What we really need is we want triangle ABC and triangle JKL are right triangles, okay, with right angles at angle C and angle L. What that will do is that will make, of course, AB the hypotenuse and JK the hypotenuse. So that's the way to go there. Okay. All right, if I want to prove those, what else do I need to know? All right, for angle side angle for this one, I'm missing a pair of angles. It looks like I'm going to need A. Angle A has to be congruent to angle J. All right, that's going to give me angle side angle. Okay. All right, next. Whoops, erased the wrong thing. Let me put that back. So angle A has to be congruent to angle J for that one. If I want side angle side, I'm going to need BC congruent to KL. And is there another one? Yeah. If I want angle side, angle side, oh, I'm going to have to use these two congruent. Okay, so angle C is going to have to be congruent to angle L. Now, even though these look like right angles, they don't have to be. We don't have to prove that. What we have to prove is that they're congruent. All right. Let me end that one, and then I'll start a brand new one, brand new video with the proofs. All right. Thanks so much.